Is that okay? That's the drivers that let Linux and FreeBSD run on Hyper-V. Talk about the distributions that are supported. Then go into some detail on some of the features. So what do you get when you run Linux or FreeBSD on Hyper-V? What can you do that's unique about that virtualization environment? I've got a short demo that's actually working this time. Some hints and tricks, tips, etc., things to watch out for if you're running Linux or FreeBSD on Hyper-V. Then I'm going to spend the last few minutes talking specifically about FreeBSD, how we treat that a little bit differently than Linux in this environment, and what we're doing specifically with FreeBSD. So the first part's going to be mostly Linux, and then I'll concentrate specifically on FreeBSD. This is a slide I love, the Microsoft Loves Linux slide. I've got my button on. I've got a few stickers and buttons left here still if you were interested in one after the session here. And I'd be happy to give out what I've got left until they're gone. So stick around and do that. But anyway, this is a slide that Satya Nadella actually put up about a year ago publicly in a briefing with press and analysts. And I think it really does capture the new thinking at Microsoft, if you will, about Linux, about FreeBSD, other operating systems beside Windows. It's not just a Windows world out there anymore. Your data center is heterogeneous. Most customers are running Windows, they're running some Linux, they're running some FreeBSD, other operating systems. And from an IT pro standpoint, you just want it to work. You know, you're not fighting operating system wars. In some sense, Microsoft's not either anymore, at least not in the data center. And so our goal is really that you can run Linux, you can run FreeBSD in a Microsoft cloud as easily as you can run Windows. You get the great functionality that you get, the integration between the operating system and the host. Frankly, you got to get great performance as well. If it's slow running Linux on Hyper-V, that's not going to cut it. We know that. We've got to make it work. And so in all of the Microsoft clouds, whether you're on-premises with a private cloud, whether you're doing Azure Stack, as that comes out during calendar 2016, if you're running in the Microsoft Azure public cloud, fundamental to all of that, of course, is Hyper-V and being able to run Linux as a guest operating system if you're going to run Linux in those clouds. So this is sort of the fundamental, it's the bottom level of the stack that makes Linux work at all the other different levels. If we look at the universe of Hyper-V functionality, understanding what part affects Linux, what part doesn't affect Linux is important. There's a bunch of functionality in Hyper-V that is outside, that's independent of the guest operating system. And there have been other sessions here at Ignite Australia, other sessions at other conferences that have talked a lot about all the great things that are being built for Hyper-V. Software-defined networking, quality of service on the storage stack, software-defined storage, storage spaces direct, all this kind of stuff. And there are different sessions on that. The good news is all of that works for Linux and FreeBSD. And so when you think about what are the capabilities that you get when you're running Linux as a guest operating system, all of those things that don't depend on the guest, it works just as well with Linux as it does with Windows. So storage quality of service works. The software-defined networking works. If I'm doing super fast live migration using RDMA, of a Linux guest, that works just like it does for a Windows machine. And so it's important to remember that, in terms of the investments that Microsoft is making, 95% of what we're doing in that larger scope just works for Linux as well as it works for Windows. With that integration? I am. So let me get to that. I think I'll get to that. I'll get to some slides talking about the integration services here in just a second. There is some functionality that does require guest cooperation. And so that's really what this session is going to focus on. There have been other sessions that talk about that other stuff. And so I'm going to narrow down and focus just on the things that really do affect Linux, that are Linux specific. But my point here is to keep in mind that what I talk about here today is not the only thing you get if you're running Linux as a guest operating system on Hyper-V. So let's talk just briefly. I get some interesting questions from time to time about what can I run as a guest operating system on Hyper-V. And so sort of the first discriminant is if I'm going to run a guest operating system on Hyper-V, does that operating system run on x86, x64 architecture? If it doesn't run on x86, it's not going to run on Hyper-V. This may sound strange, but I get, every couple of months somebody asks me, when we're going to run IBM AIX on Hyper-V, or when we're going to run IBM AIX, in Microsoft Azure. And AIX does not run on x86 architecture. It runs on Power chipset. And so it does not run on Hyper-V. It does not run on VMware. And so Microsoft's not at a competitive disadvantage here. It's just a different chip architecture. And so that's sort of a fundamental understanding that you need to have. If it does run on x86, then the question is, do you have the integration services? And I'll talk about that in more detail here. But those are the drivers that you need to run specifically on Hyper-V. Now, there's a wide variety of operating systems out there that will run on Hyper-V in fully emulated mode. That's where the disk controller and the network controller, every register is simulated in the software for Hyper-V. And that's there. We got people who are running SCO Unix, on Hyper-V. You don't get great performance because of all that emulation that's going on. CPU is good, but the disk in the network I/O is not so great. So we have people who want to run Solaris x86 on Hyper-V. It will run. I actually do it in my lab for testing System Center stuff on Solaris x86, but the performance is not great. You probably don't want to do it in production. The real ones that you want to be willing to run in production will be those where you do have integration services. And so this is where Microsoft, of course, has written integration services for Windows. It's just part of the package. And what I'm going to talk about today is integration services for Linux and for FreeBSD. And there you get the full benefits of the performance capabilities running on those synthetic devices. You get all the benefits of the integration. So this is just a top-level way of kind of thinking about it, and it kind of answers that question. This is a slide I send out when somebody at Microsoft in the field says, can I run AIX on Hyper-V? And so this just kind of gives that explanation. So again, this session is going to focus on situations where you've got those synthetic devices, you've got the integration services. Okay, so what exactly are the integration services? Hyper-V presents what we call synthetic devices to the guest operating system. Turns out that emulating a real, Intel, 21114 network controller really is not the fastest way to do I/O in a virtual machine. And so Hyper-V presents kind of this synthetic NIC, if you will, into the guest operating system. And that's designed for virtualization environments. And if you're going to have a synthetic device in your guest operating system, you need a device driver for that device. It's that simple. And so just like the operating system needs a device driver for any other device that it might be talking to. And so effectively what we call the integration services is that set of device drivers for talking to the Hyper-V specific synthetic devices. Now, unfortunately, the Windows operating system device driver model is not the same as the Linux device driver model, and it's not the same as the FreeBSD device driver model. And so we end up writing these integration services multiple times for each operating system. And so the Windows team does integration services for Windows, and it turns out my team does the integration services for Linux and for FreeBSD. And so we're writing Linux device driver code that goes into the Linux kernel for those Hyper-V synthetic devices. We also do have a couple of user space daemon processes that are needed in Linux and FreeBSD to kind of help things along in a couple of cases, and I'll point those out as we come to them. So LIS, that's what, Linux Integration Services. Our basic process here, we have Microsoft developers. We write code that runs in Linux. One way that we distribute that code is we actually create an LIS package. It's packaged as an ISO file, and it goes up on the Microsoft Download Center. And you can grab that ISO package off the Microsoft Download Center, install it into your Linux instance that's running in a Hyper-V guest, and get the benefits of LIS. That's really not the preferred path. The preferred path is what we do with the Linux community. When we make changes, when we have new versions of the drivers, we fix a bug, we improve the performance, we email it to the Linux kernel mailing list. This is the ubiquitous thing that anybody who wants to make a change to the Linux kernel sends it out to the mailing list. And the Linux community looks at it and says, gee, guys, this is okay, but you should have done this differently. We're fixing to change this, and you should make this change, and we don't like the way you put your curly braces in here. Please tweak that. And ultimately, the Linux kernel mailing list, things kind of settle down, and everybody's happy with our code. And at that point, it goes into the Linux main kernel. The upstream Linux kernel, as it is called by the community. This is the repository of Linux kernel code that is maintained ultimately by Linus Torvalds. And so the Hyper-V driver code is up there in the upstream Linux kernel. With whatever the latest version of the kernel, that's where the code goes into. It goes into the tip. And so we're up to about 4.3, I think, is the latest release one, and 4.4 version of the Linux kernel is on the way. Now that's great, it's in the upstream Linux kernel, but what about my Red Hat 7.1? And so we work with the Linux distro vendors, with Red Hat, with SUSE, with Canonical, with Oracle, et cetera, to take those drivers from the upstream Linux kernel and incorporate them into the latest and greatest distro release that Red Hat's going to do, or SUSE is going to do, or whomever. And so at that point, if you get SLES 12 or you get SLES 11, SP4, and install that into a guest VM on Hyper-V, the Linux drivers that you need are just there. You don't have to do anything special. You don't have to download from Microsoft. It's just integrated into that overall Linux distribution. And so that's the path that we're taking. We want to make it easy for you to use Linux going forward and to get good drivers as part of just the Linux distro itself. So I'm going to walk through just in terms of what are the distros that we support and that we work with. The details of all the charts here are not super important. RHEL and CentOS, of course, are clones of each other. CentOS is kind of the freeware version of Red Hat Enterprise Linux. We support all the way back to 5.5. Just like in the Windows world, we have, it's hard to get people off of Windows Server 2003. It's hard for Red Hat to get people off of Red Hat 5. I even have requests for Red Hat 4 from time to time. We've not gone back that far. We support both the 32-bit and the 64-bit versions. And we do, for the Red Hat and the CentOS, this is where we offer a download from the Microsoft website with the latest and greatest stuff, in addition to LIS being built in to the Linux distros. So, our goal going forward is to make it built in, but for those people who are running older stuff, we do have that Microsoft download to let those run on Hyper-V. A little bit about the LIS 4.0 package. This 4.0 is the newest version of that package. For about a year and a half there, 3.5 was the latest version, and it's now available in the 4.0 version. You can install it into a virtual machine that doesn't have LIS at all. You can install it into one that has LIS built in. And so it does provide the latest performance improvements. We're updating this now about every 3 to 4 months with the latest and greatest performance improvements. LIS is still changing pretty rapidly. We're still finding things that we can do to improve network performance, for example. And I'll talk about that in a minute. And so we're encouraging, if the performance is important, if you're in Azure, for example, and getting good network performance is important, getting the top network performance is important, you may, in fact, want to get the latest and greatest LIS so that you have the up-to-the-minute kinds of changes. So one thing is, if you are running RHEL, Red Hat Enterprise Linux, the certified version from Red Hat, the version that would be supported under a Red Hat subscription, is the one that has LIS built in. If you install LIS 4.0 on top of your RHEL installation, technically at that point you're no longer in a supported configuration with Red Hat. So keep that in mind. That's true even in light of the partnership between Microsoft and Red Hat that was announced just a couple of weeks ago. Ubuntu, new release every 6 months. They have the LTS, the long-term support releases, 14.04. There'll be a 16.04 coming out in April. And so we stay up to the minute with those Ubuntu releases with LIS built in. Similarly, on the SUSE side, with SUSE Linux Enterprise Server, up to SLES 11 SP4 in the 11 series, SLES 12 SP1 will be coming out here shortly. We're working with SUSE to make sure that we're up to date as much as possible with those latest releases there. Oracle Linux has 2 different kernels. They have the Red Hat compatible kernel. They also have the Oracle-specific Unbreakable Enterprise kernel. We provide support in both of those. The numbering system matches the numbering system on the Red Hat and CentOS side of the world. And then in the Debian GNU Linux, support for the 7.x series and for the 8.x series with LIS built in. Debian is not as far along in terms of the features that are supported there. We have gotten recently some better integration into the Debian community, and we're looking to get some improvement there in terms of the built-in LIS and the features that are supported there. I'll mention FreeBSD here for the moment. Again, we talk about BIS, the BSD integration services here. We've been working in the FreeBSD 10 tree, which is the current tip. And so we do have some back ports that are available as part of BSD ports all the way back to 8.4 and the 9.1, 9.2, and 9.3 series stuff. So I'll talk a little bit more about BSD toward the end of the presentation. Keeping track of the features, given that we're doing development work pretty rapidly here, new capabilities come out in Hyper-V, and then the question is, are those new capabilities in Hyper-V available in Linux? So we have some web pages up on TechNet. There is a Linux on Hyper-V section up on TechNet, and then there is a subsection for each of the distro families that we support. And we've got some big grids up there, and I put an example here that kind of shows, this is a slightly older version of the grid from Red Hat, that shows the different features and capabilities that you get when running Linux on Hyper-V, and then what is supported in which versions. And there's some empty boxes in a few cases. There's some notes along with some of these check marks that you have to read down further to see some of the details. So this reflects partly the development history, some anomalies along the way, things to watch out for. So we do encourage you to check the TechNet documentation for the particular distro and version number that you're interested in running, so that you can kind of see what you need to pay attention to there. If you're going to operate Linux and FreeBSD virtual machines on a Hyper-V host, and let's assume that you're mostly in an on-premises environment at this point. So you got a Linux virtual machine, multiple one of those, you got FreeBSD virtual machines. The way that you interact with those virtual machines on Hyper-V is exactly the same way that you would interact with a Windows virtual machine. So Hyper-V Manager, if you're doing a relatively smaller deployment, all of the UI in Hyper-V Manager, we'll look at a demo here in a minute, works for a Linux virtual machine just like it works for a Windows virtual machine. If you're scripting things against Hyper-V using PowerShell to get VM, start VM, stop VM, et cetera, all of that works for Linux VMs, FreeBSD VMs, just like it does for Windows VMs. If you're doing the full kind of private cloud stack with Virtual Machine Manager and Azure Pack, that works again operating against Hyper-V using that user interface to do those things. VMM does not support BSD at this point, so that's a Linux-only thing. And then I'll go off topic just a little bit. If you go into the cloud, this is the Azure portal. Again, ultimately Azure's running on Hyper-V, you're running Linux in Azure, you're running Linux on Hyper-V. Again, the Azure portal user interface works for Linux just like it does for Windows VMs. So sort of obvious, but that's the, just to think about, particularly some of these combinations like using PowerShell to manipulate a Linux VM, you might think, okay, that's a little weird, but in fact, the PowerShell is interacting with Hyper-V, and then Hyper-V is doing the operations on the virtual machine. So let's run down some of the features and capabilities that you get if you're running a Linux guest on Hyper-V. So this is pretty simple. You can shut down Linux guests from the management console. And this is different than powering off the VM. Of course, from Hyper-V Manager, you can do either one. You can just say turn off. It's like pulling the plug on a physical machine. But if you do shutdown from the Hyper-V console, that's actually going to interact with the Linux machine via the Linux integration services. And it's going to do the equivalent of a shutdown command, shutdown now, in fact, inside the Linux guest VM, so that you get a clean shutdown. We do time sync. So the Linux guest, when it starts up, picks up the real-time clock time, the time of day, from the Hyper-V host. If you do suspend resume, again, we're going to pick up the time from the Hyper-V host. Then a bunch of discussion going on about ongoing timekeeping within Linux guests and Windows guests. Windows guests have the benefit of typically they're domain joined, and as part of that domain join, they're tied into the Active Directory, and AD actually runs a time sync service that keeps the time of day correct on a Linux guest, even across all the scheduling and descheduling at multiple levels that can happen in a virtual environment. With Linux, we recommend that you run NTP to do the same function as that time sync that AD gives you in a Windows guest. If you don't run NTP, There is some time drift that typically occurs in a Linux guest virtual machine, and so you get some time skew there. It's something we're looking at whether we can make any improvements there. If you go to the VMware website, they've got a 32-page dissertation on time synchronization for guest VMs running on VMware ESX, and the bottom line is you should run NTP. So that's what we recommend as well on the Hyper-V side. Key value pairs. This is an interesting capability to communicate between the Hyper-V host and the guest virtual machine without using a network connection. In a private cloud environment, in fact, you may have your Hyper-V hosts and your tenants running guests really on completely disjoint networks. You don't want those tenants to be able to access the management network and vice versa. And so this allows you to pass name-value pairs back and forth between the host and the guest. These are actually used for a couple of things by our management tools. In order to know what is the IP address within the guest VM, that IP address is passed from the guest to the host just implicitly as part of a key-value pair, for example. And so it's a way that we can get some additional management information between the guest and the host. But there's also a channel in the key-value pairs that you can use from an application standpoint. So you can write applications that will pass information bidirectional between the guest and the host using key-value pairs. This is where one of the daemon processes exists. There's a Hyper-V KVPD process that runs in a Linux guest. He's responsible for coordinating the passing of the key value pairs between the guest and the host process. And there's some documentation up on TechNet about the APIs that you would use in a Linux guest in order to create a new KVP or to read an existing KVP. Generation 2 virtual machines. So, of course, these were introduced as part of Windows Server 2012 R2, kind of a slim down that discards some of the old legacy device emulation. And you boot using UEFI instead of a BIOS. This is one of the big differences. And you can PXE boot from a synthetic network adapter. So again, another big difference there. In Hyper-V 2012 R2, you cannot boot a Linux VM with secure boot turned on. And so when you create a Generation 2 VM in 2012 R2, you do have to remember to turn off secure boot in order to boot that Linux VM. Now the good news is the new symbol there, secure boot for Linux is now supported in Hyper-V 2016 version. So I'll give a quick demo of what that looks like. Most of the more recent Linux distros have the ability to boot off of UEFI, but the older versions do not. So you go back to Red Hat 5, it doesn't even know about UEFI. You can't boot that in a Gen 2 VM. You'll have to go back to Gen 1 just because the fundamental Linux kernel itself and bootloaders don't know how to do UEFI. But we've worked with the Linux distros, and the later versions do know how to do UEFI. They have the properly signed bootloaders in order to make that work. VHDX resize, this is a great feature in Hyper-V. The great news is it's immediately visible in the guest. So if you're running along, you got a Linux virtual machine running in Hyper-V. If you go into the Hyper-V, use PowerShell commandlets, for example, to change the size of the underlying VHDX, make it bigger. That's immediately visible within Linux. And so you can then go into Linux, use your partitioning tools, grow your file system, et cetera, to take advantage of the new space. So growing the VHDX, of course, it's equivalent to making the physical disk bigger in terms of what the VM sees. And then you can go back and fix up the file system structures. But you don't have to reboot. It's immediately visible from your guest VM. Let's talk about dynamic memory a little bit. This is a feature that was introduced in Hyper-V for the Windows machines. Allows you to overcommit memory. You can create virtual machines with memory sizes that are bigger, that aggregate size is bigger than the actual physical memory you have on your Hyper-V host. So that lets you get higher virtual machine density, kind of under the assumption that they're not all going to be using all of their memory all of the time. And it lets Hyper-V automatically reallocate the memory to different guest virtual machines based on memory pressure, memory demand from that guest virtual machine. And this works with Windows and Linux guests now on the same Hyper-V host. So we both Linux and Windows understand dynamic memory and can interact with each other and let memory be shared in an overcommit fashion. So how does this work? There are two mechanisms for doing dynamic memory. One is just hot add. And this adds memory to the guest operating system above the previous high watermark. So when you do dynamic memory, you start a virtual machine, it gets the amount of memory as specified in the startup memory. This is a parameter under Hyper-V. You can see it in the Hyper-V manager. And this newly added memory increases the total amount of memory that the guest operating system sees. There is no, so this is a hot add. There is no equivalent of hot remove. And so if you're going to reduce the amount of memory that's in a virtual machine, there's this mechanism called ballooning that effectively kind of creates holes in the memory map and steals the memory away. But the total memory size as seen by the guest operating system doesn't change. So if you start a VM at 1 gig of memory and hot add gets it up to 2 gigs of memory, the ballooning mechanism may reduce the amount of memory, but the high watermark stays at 2 gigabytes. So let me illustrate sort of how this works. So I've got a virtual machine, and it's been created, and the amount of memory that's been allocated is as the startup memory. So the dark blue is sort of what the memory is that the Linux guest, or the Windows guest for that matter, thinks that it has. And if I do a hot add, then the memory size as seen by the Linux guest, actually increases. If the memory demand reduces and Hyper-V decides to take some memory away, then Hyper-V effectively creates these holes in the memory map and steals some memory out from underneath Linux. But the top, the high watermark, the dark blue, doesn't change. The promise that Hyper-V makes is that it won't create so many holes that the total amount of the remaining memory in that guest goes below the minimum memory. So it knows what the minimum size that it can allow is. And at this point, if I need to add memory back into the VM again, the first thing it'll do is make some of those holes go away, is it will fill back in the holes, and ultimately it'll fill back in the holes before it raises the high watermark again with the hot add mechanism. And so this can produce what might look like some anomalous results here, and I'll kind of show in a second here. But the bottom tab here is looking at the Hyper-V manager. The startup memory was 1,024 megabytes. But the actual assigned memory to the VM is down as low as 678. So Hyper-V has stolen some memory from that Linux VM. But if you look up in Linux itself and ask, run the the free-m command, in a Linux shell, Linux thinks it's got more memory. Linux thinks it's got 862 megs. And so what's happened here is there's been some ballooning that's been done, and some memory's been stolen by Hyper-V that Linux doesn't really know that it's been stolen. So dynamic memory works well, when the memory that's required by the virtual machine varies in time, because the actual memory that Hyper-V assigns might be less than the Linux guest thinks that it has. There are definitely some cases when you don't want to use dynamic memory. So clearly, if you've got a big honking app and it just wants to grab all the memory and use it all the time, dynamic's not going to help you, It just wants all the memory. And database managers, Oracle database, some of the Java application servers, frankly, what they want to do is grab all the memory. They wish the operating system would get out of the way and not try to manage the memory for them. Those are the cases when dynamic memory is not going to be the right answer. You're going to end up thrashing as the application tries to do its own memory management, Hyper-V tries to do some memory management, and they end up working at cross purposes with each other. I do note that some of the older distros, we could only implement the ballooning functionality. There was no hot add available in that version of the Linux kernel. And if you do run one of those older versions, just make sure that you set the startup memory big enough to be equivalent to what you would want the maximum memory assigned to that virtual machine is. So we'll do a little demo here of dynamic memory in just a second. Let me talk about another feature here. The live virtual machine backup. This lets you create a full backup of a Linux virtual machine running on Hyper-V without interrupting its operation. So that's what we call it, a live backup. Now, if you didn't do anything special and you just sort of snapshotted the disk, the virtual disk of that Linux virtual machine, you would end up with probably an inconsistent snapshot, an inconsistent backup, because you haven't, Linux is doing file system buffering, there's stuff going on, the virtual disk may not be 100% up to date and consistent. And so what we've done is in the Linux integration services, we've wired these two things together so that there's a backup going on. We actually tell Linux, I'm going to do a backup. And there's a brief, like 1 or 2 seconds pause to let Linux flush its file system buffers so that the virtual hard disk is in fact up to date and consistent. so that when you take that snapshot and do the backup, you do get a file system consistent backup. Now, and the fact of the matter is, most Linux applications are very file system based, and so getting a file system consistent backup typically gives you the equivalent of an application consistent backup. There is no equivalent to VSS, the Windows VSS mechanism, in the Linux operating system. And so file system consistent backup is kind of the best that we can get here. So how does this work? This is kind of a quick little diagram. So I've got a Hyper-V host. I've got a Linux guest in that Hyper-V host. That VSS driver and that VSS daemon, actually probably incorrectly named because it doesn't really implement VSS. But those are what coordinate. Those are part of the Linux integration services that coordinate this backup process. And so what happens is the backup utility tells Hyper-V host, hey, I'm going to do a backup of that virtual machine or all the virtual machines that are on this host. And then the Hyper-V host signals the LIS that says, all right, we're going to do a backup here. And the VSS driver in the Linux kernel talks to the VSS daemon in user space, and that daemon process forces the file system buffers to be flushed. You freeze the file systems really briefly, flush the buffers, and then Hyper-V creates a checkpoint. And once it's created that checkpoint of the VHD file, or the volume that the VHD is stored on, then you can unfreeze the Linux file system. So it takes 1 or 2 seconds at most while those file systems are frozen. And then, of course, you create a snapshot of that volume, and then ultimately what you're backing up, of course, is that snapshot of that volume. But the result is you get a file system consistent backup of your Linux virtual machine. This is the same mechanism that's run on the Windows side for Windows virtual machines. Of course, Windows does have a true VSS mechanism to allow you to get an application consistent backup there. So this works, the backup utilities works for Windows Server backup. It works for third-party backup utilities. Any of these tools that have been plugged into the Hyper-V mechanism will be able to get file system consistent backups here. Yes? Yeah, the question is, in this picture, I have not drawn in the VM bus and so forth. Kind of this black arrow that goes from Hyper-V host to VSS driver, that communication is over the VM bus between the Hyper-V host and the Linux guest. And of course, ultimately, kind of this blue arrow, dotted arrow coming down to flush the file system buffers, that's a disk I/O operation. That's happening over VM bus as well. So VM bus is kind of just a lower level abstraction detail that I haven't shown in this picture. This one's complicated enough as it is. So just a couple of things about troubleshooting on the live virtual machine backup. You do have to have that daemon process running, the VSS day. If it's not running, the backup will not work. We're still working with some of the Linux distros to get that daemon process started automatically as part of the built-in LIS. So this is one of those places in the TechNet feature grid. We have a note here and there that says, hey, on this particular distro in this version, you got to do this to make sure that the VSS daemon gets started automatically. And there's some differences around different Linux file system types. There was a bug in the Linux kernel that it didn't do the freeze operation correctly on ext2 file systems. We've since gotten that bug fixed, but there are some Linux distros out there that don't do that correctly. So idiosyncrasies, this was not our bug. This was just a plain old vanilla Linux kernel bug, but we help fix those bugs as well when it's affecting something running on Hyper-V. Talk a little bit about networking and a Linux guest on Hyper-V. New feature in the 2016 release is the hot add and hot remove of virtual NICs. So you create a virtual machine in Hyper-V. It's got one virtual NIC. For whatever reason, you decide you need another NIC in that virtual machine. On the Windows side of the world and now on the Linux side of the world, you can go into the Hyper-V manager or into PowerShell and say, create another virtual NIC on that VM, and that virtual NIC will get created. You can delete virtual NICs using the same mechanism. And so that's certainly a very handy capability. We've had some customers that are in the early adopter program with the technical previews. If somebody had some kind of problem with the NIC that was built in, the networking routing got screwed up. Rather than reboot the virtual machine, he just created another NIC, got connected into the virtual machine, and sorted out whatever the problem was. Very handy kind of a thing to do. The other big thing has been network throughput. If you go back a couple of 3 years, For Linux guests running on Hyper-V, network throughput was not so good, just to be honest. We were not getting anywhere near the kind of network bandwidth that you could get if you were running Linux on a physical machine. We've implemented a bunch of new performance features, if you will. So Hyper-V does things like TCP offloads and virtual receive side scaling that spreads out the interrupt load across multiple virtual CPUs in a Linux guest so that you don't bottleneck on a single CPU. So a lot of capabilities that have been built into the network paths on physical machines. We've brought those forward into the LIS code for our Linux guests. And so a lot of instrumentation, a lot of tightened code paths. And so our typical scenario for benchmarking at this point, kind of our canonical how are we doing thing, a couple of Hyper-V hosts connected with a 10G Ethernet physical, and I got a Linux guest running on each of the Hyper-V hosts. And the question is, how fast can those Linux guests communicate with each other? What kind of throughput can I get? We use the iPerf3 performance measurement tool. This is standard in the Linux community these days. And so we run that with 16 threads. We get 8 virtual CPUs in the Linux guest so we can take advantage of the virtual receive side scaling. And at this point, we're seeing about 9.4 gigabits per second on a 10 gig Ethernet. That's saturating the physical link. That's what you'll see if you run a Windows guest on Hyper-V. That's what you'll see if you run Linux as a guest on VMware ESX, or if you run it on KVM hypervisor. So we're competitive with what you can get with other operating systems and with other hypervisors. So 10G Ethernet, that's great. 40G is starting to be out there these days. We are now working on what can we get out of a 40 gig physical link. We're in the low 30s at the moment, so not doing too bad, up from about the mid-20s, over the last 6 months. We're going to continue to work on that and push toward, getting into the upper 30s on a 40 gig link. So this is a continuing effort as the physical hardware gets faster, making sure that we can run Linux guests, Windows guests, whatever, on Hyper-V at practically the same speeds that you would get if you were running on physical hardware. That remains the North Star, the goal of what we're going to do and continue to do here. All right, so let me shift gears. I'm going to do a quick demo here. And this is going back to a system in my office in Seattle, Washington area. I'm going to start with a demo of dynamic memory. And I've got a I've got a Hyper-V host here running some Linux virtual machines. I've got a Hyper-V manager here on the left so we can kind of see what's going on. And so here's a Linux machine over here. I'm going to monitor the memory on this machine. So this every 2 seconds, this updates kind of the memory as seen on this virtual machine. Now, this virtual machine is configured. This is this one right here. It's configured with dynamic memory enabled. The startup memory was 768 megabytes, so 3/4 of a gig. And in fact, if we go look over in Linux over here, you see 736 is the total memory. There's a difference of 32 megabytes there, which I think is the frame buffer getting allocated out of what Linux sees there. So basically what I'm arguing is the memory that's seen in the Linux guest, the 736, is the same as what Hyper-V started with. Now actually what's happened is Hyper-V, the assigned memory, has moved down to 688. Hyper-V saw that this guy was sitting there not really doing anything, and so Hyper-V stole some memory from it. So it's done some ballooning to create a hole in it. Now what I'm going to do is create some workload on that Linux virtual machine. So this PowerShell window here is purely demo scaffolding, if you will, not part of what I'm really demoing. But it generates some load against that Linux virtual machine. It's got an Apache web server on it, and we're going to go generate some load there. And already you can see in Hyper-V the memory demand is going up. The assigned memory is growing. And in fact, the memory size in Linux has grown as well. So we're doing hot add functions at this point. We're adding memory, and the total amount of memory that Linux sees has grown. And at this point, that 32 megabyte difference remains. So we got 1160 assigned to it. We see 1128 in Linux. And if we give this a minute here, I think this tends to peak out at around 1205 or 1206 in terms of what gets the memory that gets assigned to it. So and if you can see the CPU load on this virtual machine is about 61%, whatever that number is at this point. So we're definitely generating some activity on that Linux virtual machine. So all right, it's peaked up at about 1198 here. All right, so I'm going to kill off the workload here. Just hit Control-C in the PowerShell window. So that goes away. And we'll immediately start to see the memory demand in Hyper-V start to fall now. The memory demand is going down, but the memory that's visible in Linux hasn't changed. And in fact, Hyper-V, the demand is going down, but Hyper-V has not yet decided to steal any memory from this Linux guest. So what I'm going to do is let this sit for a minute, because it takes it 2 or 3 minutes before Hyper-V actually decides to steal some memory from it. And let's go take a look at a different demo here. Secure boot. So if we go into the settings on this virtual machine, this is a Generation 2 virtual machine. And you can see that we have this security tab here. And so enable secure boot, that box is checked here. I am running a Windows Server 2016 version here, so I have the ability to secure boot a Linux VM. The other interesting thing is here, I have this drop down. The boot loaders on these operating systems have to be signed in order for them to secure boot properly under UEFI. And the Windows bootloaders are signed with the Microsoft Windows certificate. The Linux bootloaders are signed with this Microsoft UEFI certificate authority. So the point is there are different certificates that have signed the bootloaders from Linux and the Windows side of the world. And you have to pick the right certificate here in Hyper-V Manager or in PowerShell or whatever you're using as the management tool. So if I pick the UEFI certificate authority, I can now boot a Linux VM, Linux guest on this virtual machine. If I pick the Windows certificate authority and try to boot a Linux virtual machine, it's going to fail because the certificate is not going to check out correctly. So let me put this UEFI certificate here. We're going to click OK. And I'm just going to go to this Linux machine here and say Start. And in fact, if we open up a console window on this one, we'll see that this goes through the Linux boot process here. Linux boots in about 20 to 25 seconds. It's really fast. We'll let this go through a couple of steps where it checks out the file system. And then we will see the login here. And I can log in to this virtual machine, and I have a shell prompt. I'll also use this now as an opportunity to say, let's do the shutdown function. If I do the shutdown on this VM, sure, yes, I do want to shut down. And that happens almost instantaneously as well. And the Linux VM has been cleanly shut down via communication with the LIS layer in order to do a shutdown command. All right, let's look at one other demo here. Let's look at hot adding a VNIC into a virtual machine. So again, I'm going to do watch ifconfig, which is the Linux command for showing the status of the network. So I've got eth0 here. That's the virtual NIC in the machine. He's got an internet address, IPv4 address of 157.59.154.61. I've also got the LO device. That's the loopback device. That's the software. Exists only within Linux, and of course it's got the 127.0.0.1 address. If I go to this virtual machine and open up the settings, I can do add a new network adapter. Let me get this out of the way. Do add. We're going to map this network adapter through to the physical NIC on the Hyper-V host. I click the apply button, and voila. In the Linux guest, that new virtual NIC has shown up immediately. You'll notice it actually has an internet address. It's talk to DHCP. It's got an IP address assigned, and I have an active second NIC. You can see the packet count, the received packets, and so forth are growing as that NIC is now active on the network. And similarly, I can say, all right, well, sorry, I want to get rid of that guy. Click the remove button, and click apply. And yes, that could disrupt things, and voila. Linux has noticed that that NIC is no longer there, and it has reconfigured and cleaned up, and that virtual NIC has gone away. All right, let's take one final look now. Let's go back to our virtual memory, our dynamic memory example here. Oh my goodness, he hadn't gotten around to giving up any memory yet. I had hoped that the assigned memory there would start to go down. might have to give that guy a little more time to see the assigned memory go down. So anyway, that's the, maybe I'll pop back at the end of the session here and see if Hyper-V has caught up with what's going on there. All right, let me flip back to a few more slides here. Linux guests, a couple of tips and tricks and so forth. If you're using Hyper-V high availability, Hyper-V clusters, so that you can do live migrations, you need to make sure that you assign a static MAC address to your Linux virtual machines. If you live migrate with a dynamic MAC address, it'll end up on the new Hyper-V host within the cluster. It'll get a different MAC address, and Linux gets very unhappy if you start changing MAC addresses underneath it. That's just kind of the nature of the Linux operating system, and so this is one of those concessions that we have to make to the way Linux does its networking stuff. We recommend that you set the I/O scheduler. Linux has the ability to set at least 3 or 4 different disk I/O schedulers. And those are left over from the days of real physical disks that were spinning, that had heads that had to move between different cylinders, and you like to optimize disk I/O algorithms for elevator algorithms and so on and so forth. In the virtual world, the Linux guest has no idea what the disk structure looks like. Hyper-V is managing all of that. It's much better if you just set the Linux disk I/O scheduler to no op and just let him send the disk request straight down to Hyper-V and let Hyper-V sort out, do the optimization. Otherwise, you can end up working at cross purposes with the scheduling that Hyper-V might be doing. And then I mentioned the daemon processes on certain distributions. You do have to make sure that you get those installed properly and manually started in some cases or added to the init scripts because the distributions themselves have not done that. Something we get a question on about every 2 weeks. You're running Linux guests on Hyper-V 2012 R2 or earlier, and somebody takes a look at the event logs and they notice this message about the Linux integration services being out of date and being in an unsupported configuration. And people get concerned about that. This is a spurious message. You can ignore this message. Hyper-V is being overly sensitive here to some version number stuff. This has been fixed in the 2016 version of Hyper-V. So I just try to tell people ahead of time, you see this message about being unsupported and wrong LIS version number, just ignore it. So there is this question then about what version of LIS do I have in my Linux virtual machine? And in some sense, there is no single version number. The distributions that have LIS built in, because they're pulling that code from the upstream Linux kernel, they all show version 3.1. And again, the other thing that happens about once a month is I get a support person on the phone. They say, well, the customer had version 3.1 LIS, and I can see that there's an LIS 4.0 out on the Microsoft website. They must be woefully out of date. And unfortunately, that's not true. It's misleading. Those two numbers are not comparable. The 3.1 is not a number that should be compared against the 3.5 or the 4.0 LIS version. So check the TechNet documentation feature grids really for information on whether you need a potential upgrade. If you do have the LIS 3.5 or 4.0 package installed, you can run an RPM command, find out what's installed there, and the version number of LIS that was downloaded from the Microsoft website does show up as part of the RPM package name. And so this is a 4.0.7 release of LIS that was the output from that RPM command. So just, again, one of those things to be aware of that might look like a problem, but is not really a problem. Linux Integration Services source code. Again, this is an open source project. We send the code up to the Linux kernel mailing list. It's in the upstream Linux kernel. My point here is not to go through all the details here, but these are the path names for reference. If you go to the upstream Linux kernel at that URL, you can go see the source code for the Linux Integration Services driver. We also have the code out in a GitHub repository, and we actually, the ISOs that we build for download from the Microsoft website are built from that GitHub repository. So again, you can see the source code that makes up whatever is running there. And we do have partners who take this source code and port it into some variant of Linux that they built a virtual appliance on, for example. So there are, there's 1,000 different Linux distros out there. We have focused on those that would be running in production environments, in data centers. And so sometimes people want to run a different Linux distro on Hyper-V, and so that source code is available. People can port it, and people do port it. So that's the nature of the Linux kernel and the ability to have that source code and do your own thing there, or whatever makes you happy. All right, let me shift gears and do just a couple of slides. Microsoft loves FreeBSD as well. And really, what's the motivation here? We don't see FreeBSD much as a general purpose operating system that people are running commercial workloads on. Really, the driver here is as a base operating system for virtual appliances. It's a very stable, mature, performant operating system. The licensing, there's no GPL licensing on FreeBSD, and for some virtual appliance vendors, that's important. They want to be able to do their work and not have to open source the changes that they make in accordance with the GPL license requirements, and so they choose the more permissive GNU licensing that comes with this. But the reality is these appliances are going virtual, right? It used to be you could go buy a physical box that would be your firewall, a physical box that would be your WAN optimizer. More and more, the companies that were building those physical boxes with their software are also producing virtual images. VMware has done a great job of getting a huge number of these virtual appliances running in VMware. We're making sure that these virtual appliances run on Hyper-V as well. And the reality is some of these virtual appliances are based on Linux. That's great. We've got Linux covered. Some of these virtual appliances are based on FreeBSD. And so that's what we're trying to make sure that we can cover those virtual appliances. So customers typically don't come to us saying, I want FreeBSD. They come to us saying, I want that virtual appliance. And it turns out that that virtual appliance runs on FreeBSD. And so that's really our motivation, is to work with those virtual appliance vendors and make that work. We've recently had a developer who's made a committer into the FreeBSD kernel. So again, we participate with the FreeBSD community. The picture's a little bit different here in that we don't have the distro vendors as a second step of the process. Again, we work on the BSD integration services. We check that code into the FreeBSD Foundation maintained code repositories. There are the FreeBSD ports, and then there is the FreeBSD release itself. So we don't have the step of the Linux kernel, then going to a Linux distro. FreeBSD is just all one unified operating system together, and so that's the group that we work with, and working with the FreeBSD Foundation to produce these distributions. Status of FreeBSD on Hyper-V, it's trailing Linux a little bit in terms of the development work. We tend to do the development work on the Linux side first, then apply that knowledge into the FreeBSD world. We can't port the code. It's a different operating system. The driver model is not the same. We have to watch out for the GPL versus BSD licenses, but we do take the knowledge and move it over there. So we do have the Integration Services 1.0. It's built into FreeBSD today. It runs on Hyper-V. You don't get the great network performance. You're not getting the 9.4 gigabits on the 10 gig link like we do with Linux. The FreeBSD Integration Services, kind of the 2.0 version, is now in the 10.x tree. We've made some core improvements. We've got the KVP driver now working, some of the multi-channel VM bus stuff that allows us to interrupt multiple processors. Those are sort of foundational things for getting the high network performance. We're currently seeing maybe 7 gigabits per second for FreeBSD running on Hyper-V, working to get that up into the 9.4 range. And so there is a Integration Services 3.0 work that'll implement the segmentation offload, implements CARP. The 3.0 work is in progress at this point. It's going into the FreeBSD kernel. Over the coming months here, we'll probably see all of this stuff get in early in calendar 2016. So a work in progress, and we'll continue to work on getting FreeBSD kind of caught up with where we are on the Linux side of the world. Where do we have FreeBSD today? If you go into Azure, so go to the cloud, the Azure Marketplace, I think there's at least 4 now virtual appliances up there in the Azure Marketplace that are based on FreeBSD, of course running on Hyper-V there as customers make use of those virtual appliances. You can certainly bring your own FreeBSD to Azure. You can go get the 10.2 release that's out there, build yourself a VHD image with that FreeBSD installed in it, upload it, run whatever workload you want to on it with the current capabilities. We do have a couple of FreeBSD images, just plain old vanilla operating system images that are in the FreeBSD, in the VM Depot community area for community images that are available in Azure. So some folks have put those images up there. You can grab those as a starting point if you want to run FreeBSD on Azure as well at this point. All right, I am going to flip back just here real quickly just to show you, back to the demo. We have seen the Hyper-V finally did get active here. You can see the assigned memory for this virtual machine has gone back down to 768 megabytes. So Hyper-V has used ballooning now to steal some memory from it. Again, if you look in the Linux guest, the total memory that it sees is still 1166. It still thinks it's got that full amount of memory. Hyper-V has stolen some out from underneath it. The Linux guest thinks that that memory has been allocated to some buffers. And so that's kind of the way we fool Linux into thinking and into being able to steal some memory from it. So glad to see that Hyper-V did the right thing there. All right, so I'm going to wrap up with, Microsoft, we're committed to heterogeneous data centers. You run Windows, you run Linux, you run FreeBSD, and frankly, they work great. It's real, it's robust. We got a lot of people running it today. You go into Azure, 25% of the virtual machines running in Azure today are running Linux. That's a non-trivial number of virtual machines at this point, all running on Hyper-V. So run it in Azure, run it in your data center. It's reliable, it's performant, available today. So we love them both, Linux and FreeBSD. So complete session evaluations, please, thank you. And of course, continue on the Ignite learning path, but I will wrap it up there. I've got a very small number of these stickers left. I've got buttons left, so I'll bring these up front, and anybody who didn't get one in the previous session is welcome to grab what we've got left here. So any questions at this point? Yes, quick question.
Have you ever been flamed by Linus Torvalds?
Have we done anything with Linus Torvalds?
No, have you ever been flamed by him?
Have we ever been flamed by him? Boy, there's a long history here. I am sure somewhere in the history we have been. We were actually at LinuxCon, the conference here in Seattle back in August for the first time. And so, we're making friends with the Linux community at this point. We really are. We're working on doing that. And I've been pleasantly surprised that they've been accepting of having us come in. So.
There was a point where I think Microsoft was like they had the biggest commit.
Yeah, if you go back in time, there was a point when Microsoft had the biggest commit to the Linux kernel. We were one of the top 10, I think. It probably was like in 2011. This was at the point when the Linux drivers for Hyper-V, LIS, were first getting into the main Linux kernel. And so there was a huge slug of new code that went in. And so as part of that huge slug of new code, the actual number of commits was pretty large. Now, since then, we're not changing code nearly so quickly. And so we're back down, not at the high level that we were at that point. That was a spike in time, not something we expect to continue going forward. Any other miscellaneous questions? All right, thanks very much. I'll be around up here if somebody has something else that they want to ask about. So, yep.